Hello students, let us discuss Norton's theorem practical. In Norton's theorem, as per the definition, any complicated circuit can be redrawn as a simpler circuit in which we have one current source in parallel with Rn, that is Norton resistance, and in parallel with RL, load resistance. So now let us start with the practical, that how we are going to perform the practical. First of all, step number 1. So this is our circuit diagram. Vs is our supply voltage, that is 5 volt, 220 ohm, 220 ohm, 220 ohm. Three resistors we have used over here. RL 1 kilo ohm resistance. Now in step number 1, we are supposed to calculate current IL flowing through RL. So this is our step number 1. IL flowing through RL. Step number 2. As per step number 2, remove RL and calculate short circuit current. So now as you can see it over here, I have removed RL, that is 1 kilo ohm resistance, and now we are supposed to calculate IN, that is Norton current, short circuit current. And by removing RL, I have just connected an ammeter over here in series. Thus, we will be able to calculate IN, that is Norton current. Now let us talk about step number 3. In step number 3, you can have a look over here. In step number 3, we are supposed to calculate Rn, that is Norton resistance. For that, what I have done, I have removed Vs and short circuit. I repeat, remove Vs and short circuit. Now this is what we have got as an arrangement. So now let us calculate what is going to be Rn. Have a look over here. R1 is in parallel with R2 first of all. Why parallel? Because both the terminals are directly short circuited, or I can say directly connected with each other. Thus, parallel connection. And then this parallel connection is in series with R3 because only one terminal is connected with each other. So now let us calculate what is going to be the value. We have R1 in parallel with R2 in series with R3. So the parallel combination comes out to be equal to 110 plus 220. Finally, Rn comes out to be equal to 330 ohm. So as per the color coding, the resistance will have orange, orange and brown till 3 colors. And yes, the fourth color can have any other value. For example, gold, silver or maybe no color for the tolerance. But the first 3 bands will be orange, orange and brown. So this is step number 3. The last, step number 4. As per step number 4, IN is in parallel with Rn is in parallel with RL. Now let us see how to perform the practical for step number 4. In step number 4, right now we don't have any current source available. So what we are supposed to do for? We are going to calculate Vn, that means the respective voltage, Norton voltage, that is sufficient to generate IN. So what we are supposed to do in this case? Vn, that is the supply voltage, will be connected in series with ammeter and the remaining connection will remain same, that is in parallel with Rn, in parallel with RL. Now let us see how we are going to perform this. We will adjust this voltage from the power supply till we are supposed to get IN in this ammeter. Once we got IN, that we have calculated in step number 2 in this ammeter, note down the voltage Vn, Norton voltage. After which the ammeter will be now connected in series with RL. Do not change this voltage Vn. Whatsoever Vn you have measured over here, set over here, do not change its value now. So the last step is going to be the calculation of current flowing through RL. So what are going to be the connections? The positive of supply will be connected in parallel with RL. Then the series connection of ammeter and RL, but ultimately in parallel with Vn. So what about the connections? Positive of Vn is connected with Rn and positive of ammeter. Negative of ammeter is connected with RL, and finally negative of supply is connected with Rn, RL both. Thus you need to calculate IL, load current flowing through RL. Now this IL current will match with our step number 1, that is the current flowing through RL, and both the current will match with each other. Hence we are able to verify Norton's theorem practically. Let us design Norton's theorem. In Norton's theorem, first of all, the first circuit diagram that we are going to design, 220 ohm resistance, that is red and brown. Another 220 ohm resistance, and the third 220 ohm resistance. They all are connected together at a single terminal, so all these three must be connected in a single column like this. RL 1 kilo ohm. The input supply positive with the first terminal of 220 ohm resistance, and the negative where RL and 220 ohm resistors are connected together. So again we have a column wise connection. And finally ammeter, the positive of ammeter with 220 ohm resistance like this, and the negative with RL. Let us set the input voltage to 5 volt. So we have got 1.8 milliampere IL, the first circuit diagram. Second circuit diagram is remove RL. So this is our RL 1 kilo ohm. Remove RL and calculate short circuit current. So that means we are now supposed to calculate the current IN, that is Norton current. So the Norton current comes out to be around 6 milliampere. Step number 2. Step number 3 is regarding Rn, Norton's equivalent resistance, and that comes out to be equal to 330 ohm. What is 330 ohm? We have orange and brown. So now let us discuss the fourth step. Now regarding this fourth step, let me just show you the circuit diagram. Instead of current source, we are going to use supply in series with ammeter so as to adjust that how much voltage is sufficient for IN. So let us design this first circuit diagram. For that we require Rn. So Rn is our 330 ohm, this one. So you can have a look. Positive of supply is connected with Rn, RL both. So let me just make this connection first. So that is positive of supply is connected with Rn, RL both. After which negative of supply is connected with negative of ammeter. So this is our negative of supply connected with negative of ammeter. Finally positive of ammeter is again connected with Rn, RL both. So let me just complete this circuit diagram so that we can calculate how much Vn will be sufficient for generating In. So this is our circuit diagram, this first circuit diagram. So now let us adjust Vn so as to get In over here. So around we have got this In. Okay. So now the final circuit diagram. Now we have as already adjusted Vn. Now we are not supposed to change this voltage. Now let us design the second circuit diagram for the calculation of IL. So the second circuit diagram IL, positive of supply is connected with Rn and positive of ammeter. Negative of supply is connected with Rn, RL both. So first of all, negative of supply is connected with Rn, RL both, whereas positive is connected with Rn and positive of ammeter. So let me remove RL first and connect ammeter in series. So series means positive of supply is connected with positive of ammeter and the negative of ammeter will be connected with RL. So you can have a look. We have approximately got the same amount of current as we have got in the first circuit diagram. Hence, Norton theorem has been proved. So this is how you are going to implement both the circuit diagrams to verify Norton's equivalent circuit.